Section 2.2, Introduction to Cypher. Cypher is Neo4j's query language. It was designed to be readable, expressive, and intuitive, and it succeeds. If you have written SQL before, many concepts will feel familiar. You match data, filter it, and return results. But the syntax is built around graph patterns rather than table joins, which makes it far more natural for graph queries. Let us cover the fundamentals. There are 4 clauses you will use in virtually every Cypher query. Think of these as your core vocabulary. Match finds existing data in the graph. You describe a pattern, nodes, relationships, properties, and Neo4j traverses the graph to find all instances of that pattern. This is the most commonly used clause. Look at the example on the slide. It matches person nodes connected by a works_at relationship to company nodes and returns both. Create inserts new nodes and relationships. It is simple and direct, but beware that running create twice creates duplicate data. For the first example on the slide, running it again creates a second drug node with the same name. Merge is the smart alternative to create. It checks whether the pattern already exists in the graph. If it does, it uses the existing data. If it does not, it creates it. Merge also has onCreateSet and onMatchSet clauses that let you set properties conditionally. You can populate a new node with defaults while updating an existing one with fresh values. Merge is what you should use for all production data loading. Return specifies what to send back. You can return entire nodes, individual properties, computed values, aggregations like count and sum, and you can rename them with as aliases. Return is always the final clause in a read query. 3 more clauses you will use constantly: where, order by, and limit. Where filters the results of a match. You can use all the comparison operators you would expect: equals, less than, greater than, not equals. You can combine conditions with and, or, and not. And you have string operators that are particularly useful for graph data: contains, starts with, and ends with. You can also filter on relationship properties and use regular expressions. Look at the query on the right. It finds drugs that target the gene BRCA1, where the drug is approved and the drug name contains the string MAB, which is the suffix used for monoclonal antibodies. That is a real, useful pharmaceutical query, and it reads almost like plain English. Order by sorts the result set. It defaults to ascending. Add DESC for descending order. You can sort by multiple columns. Order by D.name, D.phase, for example. Limit caps the number of rows returned. Always use limit during development. Without it, a query on a large graph will try to return millions of rows. Skip lets you offset the result set, which enables simple pagination. Skip 10, limit 10 gives you rows 11 through 20. Pattern matching is what makes Cypher unique, and once it clicks, you will wonder how you ever wrote queries any other way. The core idea is simple. Cypher patterns look like what they represent. A node is written in parentheses. A relationship is written as a dash, then a square bracket with the relationship type, then an arrow. So the pattern for a drug that treats a disease is literally written as D:drug - treats arrow dis:"disease. You can see it. You can read it. Look at the anatomy diagram in the middle of the slide. The left parenthesized block is a node. N is the variable name we assign it, and drug is its label. The middle section is the relationship. The square bracket contains the type treats, and the arrow shows direction. The right parenthesis is the target node. The bottom 2 code examples show 2 powerful extensions of this. The first is a simple one-hop query. Match drugs that treat diabetes, filter on disease name, return drug names. The second is a variable length path query. The *1 to 3 syntax means follow between 1 and 3 relationships of any type. This lets you ask, what is within 3 hops of this gene, without knowing the path structure in advance.